In Test Case TV, what we're covering today is the use of batteries and how to combine a subset of basically AA batteries to make whatever voltage we need, since we already know how to choose our resistors and how to plan for voltages in our circuit. So that's what we're going to build off of. Plus, knowing all about capacity of batteries. So they're actually measured in milliamp hours when it's written out. And since we know that a circuit for a single LED is 20 milliamps, or 3 LEDs in parallel is 60 milliamps, we can use the overall capacity to determine how long our circuit's going to stay alive before the batteries die. So in batteries, when you see M capital AH, it's milliamp hours for a rating. So like on, you'll see it on LiPos, like a 3.7, 1600 milliamp hours, right? And it sounds crazy, but since we now know we can plan a circuit at 20 milliamps or 60 milliamps, or, as it extends, it gets bigger and bigger. What that's going to mean to us when we plan out our circuit as far as power source is the milliamp hour rating is how many theoretical amps or milliamps you can pull for 1 hour. So if I have a 1000 milliamp power source and I'm pulling 20 milliamps off of it, that circuit can last for about 50 hours before the battery is drained, because it's 1000 divided by 0.02 amps, which is my current draw for my circuit, is 50 amp hours or 50 hours. That's how that works. So when we're planning out making a power source or sourcing one, it's nice to know how we can accommodate longer times or bigger battery sources. So we'll start with the basic concept of a AA battery. All right, something you can find at a store. They are 1.5 volt a piece. All right. Now we've leveraged series and parallel before with LEDs, but let's bring that same concept towards batteries. If I put a 1.5 volt battery here and I put another one in the same orientation in line, that's 2 batteries in series. What that's going to do to my circuit is give me twice the voltage, but it's the same milliamp hour capacity. Okay, so if I want to go to a 9 volt battery, then I've got 1.5, 1.5, 1.5, 1.5, 1.5, 1.5. So I've got 6 batteries in line, but now I have 9 volts available to us. So instead of like this little square battery, which is actually kind of convenient for spacing, it may not have the capacity I want. So maybe AA batteries are what's available. So I'll improvise. And I'll do this a lot when I'm out working on projects, because I can't always find the exact source I need. So I kind of, I make do with what I can find. So with that being said, let's talk about budgeting for amp hours. A 1000 amp hour capacity for a circuit may not be long enough for a beefier circuit if we go to, say, Comic-Con. If we go to Comic-Con or build a cosplay for a whole weekend event, or a battery-powered RC car or a light show or any of these things, 20 minutes might not be enough time. This is assuming that we're pulling a lot of current, more than a single LED. So what we'll do is we'll add a battery set in parallel. And what that's going to do is 2 batteries, so a 1.5 and 1.5, but in parallel this time means we have twice the capacity overall of energy that can be drawn, but it's still the same voltage because they're not feeding through each other. It's not adding to that voltage potential. So if we have a 9 volt battery system, so we go back to the 6 batteries, and I need it to last longer, I can add another 6 batteries, and both sets at the ends go out to my voltage source, or to my circuit. That will essentially give me the option to either double my capacity or double my voltage, depending on how I arrange these batteries. And since we now know how to set up our circuit, our resistor choice, the LED's orientation based upon a voltage source, now we're going to know how to make that voltage source so everything we're doing is now available. It's now accessible. We can make a lot of things just with what we've covered right now. So with all that being said, I hope that helps. This is a shorter one, but it's very important for getting started. And if you have any questions, as always, ask down below and I will be more than happy to help out. Thank you and have a good day.